Think about a modern factory for a second. It's not just a bunch of loud machines anymore. It's more like a massive, complex orchestra. You've got thousands of robots, workers, and computers, all playing their part in this incredible symphony of production. But who or what is holding the conductor's baton? And that is the huge question for modern manufacturing, right? How do you make sure every single piece is perfectly timed, perfectly in tune, to create a flawless product without wasting a single note, a single second, or even a single watt of energy? Well, the answer comes down to a concept that's basically the secret mind of the smart factory. It's called manufacturing resource optimization, and it's the set of rules that turns all that industrial noise into a masterpiece of efficiency. So, let's pull back the curtain and see how this whole grand puzzle gets solved. Okay, before we jump into the solutions, we really need to get our heads around the sheer scale of this puzzle. This is what factory managers are up against every single day. So at its core, resource optimization is all about strategically controlling every single asset a factory has, from the big machines to the people running them to the data flying around, and just getting the absolute most out of them. And when we say resources, we're not just talking about the heavy machinery. You've got the physical assets, of course, the ones doing the actual work. But then you have the crucial human expertise, the skilled people who manage it all. And tying everything together, the cyber and IT resources, the cloud, the networks, the data, that act as the factory's central nervous system. All three of these have to work in perfect harmony. You see, with all these moving parts, a factory's natural state isn't some perfect, orderly system. It's chaos. The real magic is in taming that chaos. So let me ask you this. What happens when just one machine slows down or one team gets a little bit behind? The whole symphony can just grind to a halt. This is what's known as a bottleneck. Seriously, just picture a 4-lane highway suddenly squeezing down into one single lane. It's a total production traffic jam, and it's one of the biggest enemies of efficiency. It can cost companies millions in lost time and productivity. So how do you manage it? The old school way was just to react after everything's already gone wrong. But the smart way? It's like this dynamic 3-step dance. First, you detect. Sensors all over the factory spot a slowdown the instant it happens. Second, you analyze. The system immediately figures out what's causing the problem. And finally, you reassign. It automatically shifts other resources around to clear that traffic jam before it can cause a major pileup. But let's be real. How can any one person possibly make these kinds of split-second decisions across thousands of different machines and people all at once? They can't. And that's where our conductor finally takes the stage. And this AI conductor isn't just one single program. It's more like a whole toolkit of different AI methods all working together. You've got algorithms designed to find a good enough solution super fast because, waiting for the perfect one would just take too long. You have machine learning, which basically acts like a fortune teller, predicting future problems. And then you have systems that manage the entire supply chain like a perfectly coordinated team. And listen, this isn't just about making robots work harder. Not at all. There's a really important human side to all this. AI is now being used for something called cognitive load-aware shift scheduling. It's a bit of a mouthful, but it just means the AI builds work schedules that help prevent worker burnout. It perfectly matches the right person with the right skills to the right task, making their jobs a whole lot easier and more effective. Okay, so we've got this amazing AI conductor running the whole show, managing this complex orchestra. What does that actually mean in the real world? What do the results look like? Well, check this out. A recent study looked at exactly what happens when you let an AI manage both the routing of vehicles and the scheduling of tasks at the same time. The results are, well, they're pretty staggering. First, let's look at the data network, the factory's nervous system. Its peak utilization hit a whopping 91.2%. That means the system was firing on all cylinders with almost no capacity going to waste. Next, what about the thing that really matters? Getting stuff out the door. The order completion rate shot up to 95.1%. I mean, that's the bottom line, right? Getting the product made and to the customer on time. And this one might be the most incredible of all, the system's reaction time. The average delay from end to end was just 89.4 milliseconds. That is unbelievably fast. We're talking about the whole system detecting a need and taking action almost instantaneously. And if you want to see it all in one picture, this chart says it all. With traditional scheduling, look at all that idle time. Those are expensive machines just sitting around waiting. But with AI optimization, that wasted time gets absolutely crushed. You're just getting so much more done with the exact same resources. But in today's world, being fast and being cheap, it's just not enough anymore. The next big mountain for manufacturing to climb is all about going green. Yeah, so that means this modern optimization isn't just juggling speed and cost. Now that AI conductor has a third ball to keep in the air, minimizing the factory's carbon footprint. It's become a tri-objective problem, all about turning that raw efficiency into real sustainability. But there's a pretty big roadblock here. As this quote explains, everyone wants to be green, but the industry doesn't really have a standard way to measure energy use and carbon output. Without that universal yardstick, it's really hard to compare different methods and make real lasting progress. So, where does all this leave us? What does the future of the smart factory look like now that we know about its secret mind? All right, let's put it all together. Here's what you really need to take away from this. We've seen that a smart factory is this incredibly complex orchestra of physical, human, and digital parts. We learned that AI is the only conductor fast and smart enough to actually lead it, stamping out bottlenecks and unlocking huge gains in efficiency. But the most important thing to remember is that the next frontier, it isn't just about being faster. It's about using that exact same intelligence to become truly sustainable. And that leaves us with one last really crucial question. We have the AI conductor. It's ready and it can optimize for pretty much any goal we give it. The challenge for us now is to write the right music, to clearly define what a truly sustainable and efficient future looks like, so the AI can help all of us perform it.